Good evening, everyone. Welcome to the last session of this course, Digital Signal Processing and its application. Today we are going to discuss the tutorial session for some of the important questions across all over the week. This is just the extra session. We'll start the lecture. First question is, and also this video is recorded. Let me check whether recorder is on or not. Yes, it is recording. So after recording, this video will be uploaded on YouTube. So a student who is not able to watch now can see this same video on YouTube. And if you have any doubt, then you can ask your doubts in the comment section of the YouTube. So the first question is the analog signal xt. Xt is given, that is equal to 2 cos 2000 pi t plus 3 sine 6000 pi t plus 8 cos 12,000 pi t. Now xt is sampled at the sampling frequency fs is given as 5000 hertz. So what is the discrete time signal obtained after sampling? So let's substitute t is equal to n capital Ts and our x and Ts. Ts will become here, like we have to put Ts is equal to 1 by Fs. So this will become 1 by 5000. So now put that 2 cos 2000 by n by 5000 plus 3 sine 6000 pi n by 5000 plus 8 cos 12,000 pi n by 5000. So the final answer will become 2 cos 2 by 5 pi n plus 3 sine 6 by 5 pi n plus 8 cos 12 by 5 pi n. So the correct answer is option A. So now we will move on to the next question. Which of the following statements are true regarding the convolution of sequence x1n is equal to 1, 2, 3, 4, and x2 of n is given as 4, 3, 2, 1. Write x1n here and this side x2n. So this will be 1, 2, 3, 4, and again this side is 4, 3, 2, 1. So this will be 4, this will be 3, 2, 1, 8, 6, 4, 2, 12, 9, 6, 3, 16, 12, 8, 4. So the x3n, that is the convolution of x1n convolution with x2n. So this will become 4, 11, 20, 30, 20, 11, and 4. Sorry, the answer will be 30. The first time I did mistake because when you do sliding and that time you will get 30 as the value. So this is the method for convolution and the answer is 30. Okay. So now we'll move on to the next question. So in this question, xn is given and hn is given, and we have to find the convolution of this system. So for finding convolution, first we will do x of like h of minus n. So it will become our xn is equal to at 0 it is 1, 1, 2, 3 it is 1, and after that it is 0. So what is our h of minus n? So our h of minus n will be like h of 0 will be 2, and then h of minus 1 will be 2, and then h of minus 2 will be also 2, and h of minus 3 will be also 2. Okay, and for other value it will become 0. So y of n will be, now when you multiply this you will get as a 2, and again use this is h of minus n. Now you do h of minus n plus 1, and then you do multiplication, you will get 4, then again we will get 6, then again we will get 8, then again we will get 6, again 4, and again 2. So this is the convolution of the given sequence. So option C is the correct answer for this question. So one of the properties of Z transform that is given, that is nx of n. So the Z transform of this is minus Z d of xz divided by dz. Okay, so we have to find the inverse Z transform of the, find inverse Z transform of xz is equal to z by 1 minus z whole square. For finding the inverse Z transform, we can equate this as this is equal to minus z d by dz and 1 minus 1 by z. Okay, so when you do this we will get the following value in the left hand side. So as we can see that, so for xn is equal to un, the z transform is 1 by 1 minus 1 by z, but it is in this form. So this value xn, like this will be n into un. So inverse Z transform of this is n into un. Just give me a minute break, then we'll move on to the next question. Now let's see duality property, because that is very very important. Let's suppose the Fourier transform of xt, that is given as xw, then the Fourier transform of capital Xt will become 2 pi x small x of minus w. Okay, so first we will see proof also. So xt is equal to, like, that is the inverse Fourier transform of capital X of omega. So we can find xt like this. So now 2 pi xt is given as integration over minus infinite to plus infinite x omega e to the power of j omega t d omega. So now let's substitute e as a minus omega. So it will become 2 pi x of minus omega, and this will become minus infinite to plus infinite xt e to the power of minus j omega t dt. Okay. So we will get 2 pi x minus omega as Fourier transform of xt. Understood? So this was one of the concepts of duality. We will take one pictorial example, like this is minus tau by 2 and this is tau by 2. This is the rectangular signal. The value is 1 from t is equal to minus tau by 2 to tau by 2. So the Fourier transform is for this is sinc. So the sinc function we can draw. So this is our sinc function. So now whenever we do like the Fourier transform of sinc. Now sinc is in the time domain, let's suppose. Here it is in the frequency domain. Okay. Now when the sinc is in time domain, and here it was x omega, then the frequency, like the Fourier transform is given as 2 pi into x of minus omega. So it will become, this value will become 2 pi. So let's suppose we will write in the formula wise. So rectangular t by tau, that is having Fourier transform given as tau into sampling function omega tau by 2. So tau sampling function is the same function given there. So this will have the Fourier transform as 2 pi rectangular function of minus omega by tau. Okay. Since rectangular function is like even function, so we can write it as a 2 pi rectangular omega by tau. So in this way we can write. So now let's find the Fourier transform of the following. Xt is equal to 1 by 1 plus t square. The second is xt is equal to 1 by 1 plus jt. Third is xt is equal to 1 by pi t. Okay. So we have to find the Fourier transform of each thing. So we will use the property of duality. So we can see here, like we know that the Fourier transform of e to the power of minus a mod t is given as 2a divided by a squared plus omega squared. Okay. And let's take a is equal to 1. So in that case, e to the power of minus mod t will have Fourier transform as 2 by 1 plus omega squared. So let's suppose this is our xt and this is our x of omega. Okay. So now the Fourier transform of capital XT will be 2 pi x of minus omega. So capital XT, what it will be? 2 by 1 plus t square. So this will have the Fourier transform as 2 pi e to the power of minus omega. Okay. Now this 2 and this 2 will get cancelled. So Fourier transform of 1 by 1 plus t squared. This is given as pi e to the power of minus mod omega. Now for the second question, we have to find the Fourier transform of 1 by 1 plus jt. So these all are little complex Fourier transform. So we can solve using the property of duality. Xt is given as 1 by 1 plus jt. Okay. So we know that the Fourier transform of minus e to the power of minus at ut is given as 1 by a plus j omega. So e to the power minus t ut will have Fourier transform as 1 by 1 plus j omega. So now here xt will have Fourier transform as 2 pi small x of minus omega. So we have to substitute here t is equal to minus omega and 2 pi x of minus omega. So we will get 1 by 1 plus jt will have the Fourier transform as 2 pi minus e to the power of omega. So it is minus minus omega and ut is also u minus omega. So this will become 2 pi e omega u of minus omega. Okay. Now the third question is xt is equal to 1 by pi t. So xt is equal to 1 by pi t. So we know that Fourier transform of signum t is given as 2 by j omega. So 2 by jt will have Fourier transform as 2 pi signum of minus omega. Okay. So this 2 and 2 will get cancelled. 1 by jt will have Fourier transform as pi signum of minus omega. So now 1 by pi t will have Fourier transform as, we'll take j that side. So j of signum minus omega. Okay, and signum function is odd function. So that is, so this we can write as minus of signum omega. So 1 by pi t will have Fourier transform as minus j of signum omega. Okay, so up to this, it is done. So now we'll take one more example. Find the inverse Fourier transform of x omega is equal to u of omega. We all know that the Fourier transform of unit step function ut is pi del omega plus 1 by j omega. So now u of minus t will have Fourier transform as pi of del minus omega, that we are just using the time reversal minus 1 by j omega. So del omega is a even function. So we can write it as pi of del omega minus 1 by j omega. Now from duality, what we can do, we can find the Fourier transform of pi del t minus 1 by jt. What it will be? It will be 2 pi small x of minus omega, 2 pi u of omega. Okay. So we have to find the Fourier transform of u of omega. So we'll take divided by 2 pi on both the sides. So we will get del t by 2 minus 1 by 2 pi j_t. This will have Fourier transform as u of omega. Okay. So the inverse Fourier transform of u of omega, this is given as del t by 2 minus 1 by 2 pi j_t. Okay, so up to this it is clear. Now we will see Z transform also, because there lots of topics were taught with respect to Z transform and filter in this course. So for for any discrete time signal xn, if Z transform is defined as zt of xn is given as summation of xn z to the power of minus n, where n is equal to minus infinite to plus infinite. Okay, and z is r e to the power of j omega. R is distance from origin in z plane, and omega is the angle from the positive real axis in z plane. Okay, so we'll solve some question. We'll start with some easy question. So the unit step response of the system described by difference function yn plus y of n minus 1 is equal to xn is. So we'll by taking the z transform, like it is given yn plus yn minus 1 is equal to xn. So when you take z transform on both the side, we'll get yz plus z inverse y of z is equal to x of z. Okay. So now take yz as common. We will get 1 plus 1 by z is equal to x of z. This implies that y of z is equal to, or either we can take z plus 1 by z. So z by z plus 1 into x of z. So, but here in this question it is given that it is a unit step response. So input is xn is equal to u of n. So our x of z will become 1 by 1 minus z inverse. So that is equal to z by z minus 1. Okay. So y of z, this will become z by z plus 1. Just give me a time. Z by z plus 1 into z by z minus 1. Okay. So this will become z square by z square minus 1. Now this is a very good question. Solve the difference equation yn plus 3 of y n minus 1 is equal to x of n. Now it is given that initial conditions are given. Y of minus 1 is given as 1, and we have to determine yn for the input. Xn is equal to 8 into u of n. Okay, so let's solve this question. So yn plus 3y of n minus 1 is given as xn. Xn is equal to 8 of u of n. And also it is given y of minus 1 is equal to 1. So we can write this y of n minus 1 like applying unilateral Z transform. So I will just mention this properties of unilateral Z transform xn is given as x of z, and x of n minus 1 will have z inverse x of z plus x of minus 1. Okay, so this is the property. So here we'll apply the same property. So we will get y of z plus 3 z inverse y of z plus y of minus 1 is equal to 8 u of n. And sorry, the z transform of un will be 1 minus z inverse. Okay, so we have taken z transform on both sides. So we will get, now we'll take y of z common. So we'll get 1 plus 3 z inverse plus 3 into 1 is equal to 8 by 1 minus z inverse. Just give me a time. So yz 1 plus 3 z inverse plus 3 is equal to 8 by 1 minus z inverse. So yz, now we will take 1 plus 3 z inverse is equal to 8 by 1 minus z inverse minus 3. So y of z will be minus 3 by 1 plus 3 z inverse plus 8 by 1 minus z inverse multiplied with 1 plus 3 z inverse. So here we can do the partial fraction expansion. So we can write az as minus 3 by 1 plus 3 z inverse plus a by 1 minus z inverse plus b by 1 plus 3 z inverse. So after partial fraction, what will be a? The value of a will be, we have to multiply with 1 minus z inverse, then we will substitute 8 by 1 plus 3 z inverse, substitute z inverse is equal to 1. So we will get 8 by 4, that is equal to 2. B is equal to, again it will become 8 by 1 minus z inverse, and here z inverse is equal to 1 by 3. So substitute 1 by 1 minus 1 by 3. So it will become, so z inverse is equal to 1 by 3. So here it will become z inverse equal to minus 1 by 3, because it is there 1 plus 3 z inverse. It will become like this. So it will become 4 by 3. So it will become 24 by 4. So it will become 6. So now we can write as y of z is equal to minus 3 by 1 plus 3 z inverse plus a. A is here 2 by 1 minus z inverse. B. B is here 6. 6 by 1 plus 3 z inverse. Okay. So we can write as y of z is equal to 6 minus 3, that is equal to 3 by 1 plus 3 z inverse plus 2 by 1 minus z inverse. So this we can write it as 3, like y of n is equal to 3 into minus 3 to the power of n u of n, because this is 1 by 1 plus 1 by 3 to the power of z inverse. So it will become minus 3 to the power of n un plus 2 into u of n. So the final answer will be 3 into minus 3 to the power of n plus 2 into u of n. Okay. So now we'll try to solve some filter based question. Just give me a minute. So obtain direct form and cascade form realization for the transfer function of Hz is equal to 1 minus 1 by 4 Z inverse plus 3 by 8 Z to the power of minus 2 multiplied with 1 by 1 minus 1 by 8 Z inverse minus 1 by 2 Z to the power of minus 2. So first we will do the direct form realization and then we will find the cascade realization of the same. So h of z, when we do the multiplication, we will get 1 minus 1 by 4 plus 1 by 8 z inverse plus 3 by 8 plus 1 by 32 minus 1 by 2 z to the power of minus 2. Now for minus z to the power of minus 3, we will get minus 3 by 64 plus 1 by 8 z to the power of minus 3. Then minus 3 by 16 z to the power of minus 4. So we will get 1 minus 3 by 8 z inverse minus 3 by 32 z to the power of minus 2 plus 5 by 64 z to the power of minus 3 minus 3 by 16 z to the power of minus 4. So now we can represent as a FIR, finite impulse response direct form. So this is given as the input xn, the delay unit z inverse. So xn minus 1 is having the multiplier constant minus 3 by 8. Then z minus 2 is having minus 3 by 32. Z minus 3 will have 5 by 64. Then again Z inverse will have minus 3 by 16. So this is the direct form realization. Now for cascade realization, we will take hz as the same way how it was given. So this was given as 1 minus 1 by 4 z inverse plus 3 by 8 z to the power of minus 2, 1 minus 1 by 8 z inverse minus 1 by 2 z to the power of minus 2. So this is our h12 and this is our h22. Okay. So the delay unit z inverse will have coefficient minus 1 by 4 z to the power of minus 2 is having in the first system is plus 3 by 8. Now it is cascade, so we'll take for h2z. For h2z, the first delay unit will have minus 1 by 8. Then second delay unit will have minus half. And in this way, we will get y of n. So this was one of the question. Just give me a minute. So we can end the lecture here only. Well, so this was the questions which we solved today. Thank you everyone. And this video will be uploaded on YouTube and people can watch and comment if they have any doubt. Thank you. Bye bye.